Here we have a SAT math problem. Okay, let's go to the question. How does the graph of f of x equals to x square negative 4x positive 5 compare with the graph of g of x equals to x square? So that is we have to compare the graph of f of x with the graph of g of x. Okay, now let's go the answer choices. In answer choice A, the graph of g of x is moved to the left 4 units and up by 5 units. Okay, here we have some transformations on the graph of the function g of x. Okay, in answer choice B, C, and D. In the rest of the answer choices also, we have some transformations on the graph of g of x to get the graph of the function f of x. Okay, here both the functions are quadratic functions, the f of x and g of x. Okay, now to identify the transformations on the function g of x, to get the graph of the function f of x, we have to write the function f of x, I mean the quadratic function f of x, in vertex form. That is f of x equals to a times x negative h whole square positive k. Okay, here when I write the quadratic function f of x in vertex form, so this a represents the stretch or compression, and the h over here represents horizontal translation, k over here represents a vertical translation. Okay, now to find the transformations on the function g of x, so our aim is to write the quadratic function f of x in vertex form. Okay, now let me take the function f of x as it is. That is f of x equals to x square negative 4x positive 5. Okay, here f of x equals to x square. Now let me consider an algebraic identity, that is a negative b the whole square, that is a square of a binomial. So the expansion of the square of a binomial over here is a square negative 2ab positive b square. Okay, here let me write this negative 4x as a negative 2 times x times 2. Here we may have a question. Why do I have to write this 4x as 2 times x times 2? Because here I want to get an expression exactly in this form, a square negative 2ab. Okay, now this expression is exactly in this form, a square negative 2ab. At the place of a we have x, at the place of b we have 2. Okay, if I want to get an expression exactly in this trinomial, what is missing over here? B square is missing. B square means 2 square is missing, because at the place of b we have 2. Since the 2 square is missing, let me add 2 square over here. To adjust the addition of this 2 square, let me subtract 2 square over here. So actually it is its value is 0, positive 2 square, negative 2 square. So still this is equal to this of x square negative 4x, because here we have x square, and the simplification of this 2 times x times 2 is 4x, and its value is 0. Now we can write this value positive 5 as it is. Okay, here when I do a complete simplification of this expression, it is equal to the original stuff we have over here. Okay, let me continue. F of x equals to, now let's consider the trinomial we have over here. It's exactly in this form, a square negative 2ab positive b square. At the place of a we have x, at the place of b we have 2. Since this trinomial is exactly in this form, we can write this trinomial as a square of a binomial, like a negative b the whole square. So at the place of a, what I have to do is I have to write x. At the place of b, we have to write 2, that is x negative 2 the whole square. Now we can write this negative sign as it is, and the value of this 2 square is 4, positive 5. Okay, f of x equals to x negative 2 the whole square. When I combine this negative 4 and positive 5, I'm getting positive 1. Okay, now I got the quadratic function f of x in vertex form, that is f of x equals to a times x negative h whole square positive k. And also let me write the function g of x over here, that is g of x equals to x square. Now we have to compare the function f of x with g of x. Okay, here we have x square. Instead of x square, we have x negative 2 the whole square. And also here the coefficient of x square is just 1. And here the coefficient of x negative 2 the whole square is also 1. That is the value of a is 1. Since the value of a is 1 over here, there is no stretch or compression. Okay, here at the place of x we have x negative 2. That is 2 has been subtracted from x. Okay, whenever some value is subtracted from x, it represents an horizontal translation to the right. So that is we have to translate the graph of the function g of x to the right 2 units. And here at the place of k, what do we have? We have 1. Actually, as I said earlier, this k, the value of k represents a vertical translation. Since the value of k is positive 1, so it's a vertical translation up 1 unit. So when we compare the function f of x and g of x, so we have to do 2 transformations on g of x to get the graph of the function f of x. That is horizontal translation to the right 2 units, and vertical translation up by 1 unit. So we find this stuff exactly in answer choice D. That is, the graph of g of x is moved to the right 2 units and up 1 unit. The correct answer choice for this question is D.